Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. I'm teacher Pasco, and today I will be with senior 2 students, continuing with unit number 6, and the lesson is the preparation of salts, preparation of soluble salts. In the previous lessons, we discussed salts, and in this unit, as the name shows, it is called preparation of soluble salts, preparation of salts and identification of ions. So what we have been discussing is the parts of this unit, but the main part, which is the preparation of salts, will be started today. And because we have different types of salts, if you remember, we have studied the solubility of salts. And from the previous units, we have seen some of the reactions. Do you remember the precipitation reaction? The precipitation reaction is used to make or to synthesize, to prepare insoluble salts, meaning that we have 2 types. Depending on solubility, we can distinguish 2 main types of salts: soluble salts and insoluble salts. And because of that, we have different methods of preparing those salts. So today, we will go deep and analyze the methods we can use to prepare soluble salts. Objectives: at the end of this lesson, you should be able to describe different methods used to prepare soluble salts and write and balance equations of the reaction that take place while preparing these salts. The preparation of salts is a chemical process. So when we prepare them, a chemical reaction takes place. And each reaction can be represented by a specific equation, a particular equation. So you should also be able to write those equations, balance them, and you should never forget to put there the state symbols. Preparing salts from a reaction of an acid with an active metal. Think about an example of an acid. An acid, you know. And here we are starting with an acid and an active metal. Think about the acids you remember that we can use and the active metals we can use. Active metals means what? Active metals means metals which are very reactive, which can react easily with the acids. So here we have an example. And before we look at the example, let us read. Active metals react with dilute acids to produce salts and hydrogen gas. We have the example here, you can see it. Zinc is one of the active metals. I think it is also one of the metals you have suggested that can be used. And this is sulfuric acid dissolved in water that can also be used. Other acids we can use are like hydrochloric acid, nitric acid, phosphoric acid, and so on. But the most common, we know there are nitric acid, sulfuric acid, and hydrochloric acid. I'm very sure those are the ones which are very common to you. And we have zinc, but apart from zinc, we have aluminum, magnesium, calcium. Those are also some examples of the active metals we can use. So when you take a metal like zinc in the solid state and react it with aqueous dilute sulfuric acid, we produce zinc sulfate plus hydrogen gas. you can see that this zinc sulfate is in aqueous solution. What does it mean? It means that our salt is soluble in water, so you cannot have it in the solid state. Here you have to be very careful, because there is something important here we have to note. Because these substances, these salts, are soluble in water, and when you carry out your reaction, they will be produced, but in a dissolved state or in aqueous state. If you want to prepare solid particles of those salts, you should proceed with a process we call crystallization, the formation of crystals. Do you remember how we carry out crystallization? Yes, you remember. Crystallization means making crystals. So if you have a solution which contains an ionic salt, you can evaporate some of the water. The excess water should be evaporated. And as you evaporate, your solution will get concentrated. The amount of solute will remain the same, while the amount of solvent will be reducing. So when you get a saturated solution and supersaturated solution, at a given time, solids will start to form. And the solids are the ones we call crystals. So you should always proceed with crystallization after producing this solution. You evaporate the excess water up to the point that solid particles will start to form. And then the hydrogen gas, which is here, will escape from the reacting mixture. Here we have more examples. And these two examples, I want you to try them before we can correct them together. Write balanced equations, including state symbols for the reactions below. We have dilute hydrochloric acid and aluminium, dilute nitric acid and magnesium. From this example, the worked example we have here, you use a solid metal and a dilute acid to produce an aqueous salt and hydrogen gas. So you can refer to this one and try these two questions. You have 30 seconds for each equation. Dilute hydrochloric acid and aluminium, you will use the symbol equations. You don't write word equations. And dilute nitric acid and magnesium. Don't forget to put there the state symbols, as I said. And if you don't remember how to write the molecular formula of these substances, then you can take your time and revise. We have covered this in Senior 1 and the previous units of Senior 2. Okay, good. Now let us correct number 1. Number 1, we have hydrochloric acid reacting with aluminium, and as I said, aluminium, this is the metal, should be in this solid state, while aqueous, this hydrochloric acid will be in aqueous state. Now, what do we produce when aluminium combines with chlorine? Here you should remember the valence of aluminium cation and that of the chloride ion. So aluminium has 3 positive. The cation has a charge of 3 positive, and chloride ion has 1 negative. So if we cross the values, what do we get? We get 1 here and 3 here. And the compound we form here from this will be aluminium chloride, like that. So we produce aluminium chloride. Remember, it will be in water, so it is in aqueous form, plus hydrogen. This type of reaction will always produce hydrogen. And now, what is next is to balance. Check if your equation is balanced. We have 1 chlorine here, but here we have 3 chlorine atoms. Here we have 2 hydrogen atoms, but in the reactant side we have 1. So how do we balance? We have different methods of balancing, but because today's lesson is not balancing chemical equations, so we will not go in the details. What we need is to have the equation balanced. So here we use 6 and 3 to put 2 here and 3. So now we have 6 hydrogen atoms, and here also we have 6 hydrogen atoms, 3 times 2. For chlorine we have 6, and in the product side we also have 6, 3 times 2. Aluminium, we have 2 aluminium, and here we should have 2 also. And our equation is completely balanced. We go to the next. We have nitric acid, it's this one, in aqueous state, plus magnesium in the solid state, and we produce. Do you know what we produce? The name is magnesium nitrate. How is it written? Magnesium has 2 as the charge, and the nitrate ion has 1, -1. So if we cross, we get what? We get magnesium NO3, 2, the substance which is also soluble, so it will be in aqueous state, and we add hydrogen gas. And after this, we have to balance. We have 2 hydrogen atoms and 2 nitrate ions. And on the reactant side, we have 1, 1, so we put there 2. Like this, we have our equation balanced. You will have more exercises in the homework. So we go to the second method. The second method is preparing these soluble salts from a reaction of an acid with carbonates and hydrogen carbonates. Do you remember the formula of carbonates and hydrogen carbonates? Do you remember some of the carbonates and the hydrogen carbonates? Yes, I'm very sure you do remember them. So here we have the examples we will analyze. And every time when you take a carbonate or a hydrogen carbonate and react it with a dilute acid, you produce a salt, that is the first product. You produce carbon dioxide, and the other product is water. So we always produce salt, carbon dioxide, and water. As we can see in the 2 examples, sodium carbonate reacting with hydrochloric acid, we produce sodium chloride plus water plus carbon dioxide. So the metal from this carbonate will combine with the anion from the acid. I repeat, the metal from this carbonate or the hydrogen carbonate will combine with the anion from the acid. You can see sodium from sodium carbonate has combined with the chloride ion from hydrochloric acid. In the same way, sodium from sodium hydrogen carbonate has combined with the nitrate ion from nitric acid, and the other parts are water and carbon dioxide. And here we have some examples. Right balanced equation is the same as what we did for the first method of preparing these salts. Write balanced equations, including state symbols for the reactions below. Dilute hydrochloric acid and calcium carbonate. Here it is very important to remind you that you should know how to write molecular formula. If we don't remember how to write molecular formula, it will be very difficult for us to write these equations and balance them. So you should keep on revising how to balance on how to write the molecular formula of equations and the compounds, sorry. Number 2, we have dilute sulfuric acid reacting with potassium hydrogen carbonate. 30 seconds for each. Thirty seconds for each equation. Remember to include the state symbols. How do we know those state symbols? We said the acids are dilute. If they are dilute, then they are in water, so it is in aqueous solution. And the salts we are preparing, they are also soluble in water. So they will be in aqueous form. And water is liquid, and carbon dioxide is a gas at room temperature and pressure. Answer for the first equation. We have dilute hydrochloric acid reacting with calcium carbonate, HCl plus calcium carbonate, solid, and what do we produce? We produce calcium chloride, a soluble salt, plus carbon dioxide, it's a gas, and water, which is liquid. Is our equation balanced? No. We have 2 chlorine atoms in the product side with 1 chlorine in the reactant side. So we put 2 here. If we put 2 here, we have 2 hydrogen atoms. Here we also have 2 hydrogen atoms. Chlorine, we have 2 and 2. Calcium, we have 1 and 1. Carbon is 1 and 1. And for the oxygen atoms, you can see we have 3. And here we have 2 and 3. So our equation is balanced. And the second is a reaction between sulfuric acid and potassium hydrogen carbonate. Potassium hydrogen carbonate plus sulfuric acid, we have, what do we get? As I said, the metal will combine with the anion from the acid. So potassium combines with sulfate ion, and we put 2 here. You remember the reason? It is a soluble salt plus carbon dioxide gas and water in liquid state. Is it balanced? No. Here we have 2. So we put 2 here to have 2 potassium, and here we have 2 hydrogen atoms, 2, we have 4, so we put 2 here. And for the carbonate ion, we also have 2. We have 2 hydrogen carbonate ions and 2 carbon dioxide. Now let us check if it is balanced. Potassium, 2. Hydrogen, we have 4. There we have 4. Carbon, we have 2, and here we have 2. Oxygen, we have 4 plus 3, that is 7. Here we have 4, 8, 10. So what we have here is not balanced. So we have to change this. Change. We have 1 potassium, and here we have 2. And then what do we have to do? If we put 2 here, and we have 2 on the reactant side, 2 moles of potassium hydrogen carbonate reacting with 1 mole of sulfuric acid to produce 1 mole of potassium sulfate plus 2 carbon dioxide and 2 H2O. Now we check if our equation is balanced. We have 2 potassium, 2 potassium. 2 hydrogen atoms plus 2 hydrogen atoms. Here we have 4. And for the carbon, we have 2 carbon atoms, and in the product side, we also have 2. Oxygen atoms, we have 6 and 10. Here we have 4, 8 and 10. And for sulfur, it's balanced, 1 sulfate ion and 1 sulfate ion. So our equation is balanced. And these are not the only methods we use to prepare soluble salts. The next method is the preparation from a reaction of an acid with a metal oxide. When acids react with metal oxides, like in this example, we produce a salt and water. We produce a salt and water. The oxide will be in the solid state and the acid in aqueous state to produce a salt which is in aqueous state and water which is in the liquid state. We have 2 examples you have to try. We have dilute hydrochloric acid plus zinc oxide. What do we get? Let me do this one for you, and you try the second. HCl aqueous plus zinc oxide. What do we produce? What will be produced? The metal cation will combine with the anion from the acid, while hydrogen and oxygen will combine to give water. So we have zinc chloride plus H2O, liquid water. Now complete this one. Dilute nitric acid reacting with calcium oxide. Complete it, please. Some seconds, and you hurry up, please. So we have the metal which combines with the anion from the acid, and hydrogen combines with oxygen to give water. And the products will be calcium nitrate. Remember, they are soluble salts, plus H2O liquid, and here we have 2, and we produce water. So this is the nitrate ion, 2 nitrate ions and 2 nitrate ions, 2 hydrogen, and calcium is 1, and oxygen is 1. So the equation is balanced. And the last method we have is preparation from an acid and a base. Do you remember the name of a reaction in which an acid reacts with a base? How do we call it? We call it a neutralization reaction. It's one of the 2 types of double replacement or double displacement reaction. One is precipitation, the other one is neutralization. So when an acid reacts with a base, we always produce a salt and water. The example we have sodium hydroxide plus sulfuric acid producing sodium sulfate and water. And we have 2 examples here. We have hydrochloric acid. I want to do this one for you. Hydrochloric acid reacting with calcium hydroxide. What do we produce? The metal combines with the anion from the acid, and we produce calcium chloride. And the other product, as we said, it is always water if the reaction is neutralization. And then you balance. we have one chlorine here, but here we have two, so we balance like this. The equation is balanced. And the second one, we have phosphoric acid. Think about the molecular formula of phosphoric acid. I give you some seconds. Phosphoric acid. Hint, there is phosphorus in there. Hydrogen and oxygen. What is the molecular formula? It is H3PO4. Reacting with what? Reacting with potassium hydroxide. And what do we produce? We produce potassium phosphate plus H2O. We have 3 potassium, so we put 3 here. And then we have 3 moles of water. And we are done with the methods we use to prepare, the common methods we use to prepare soluble salts. Now let us read the homework. Homework, complete the equations below. Sodium hydroxide reacting with nitric acid. You will remember to write the state symbols and balance. Don't forget that. It's very important. Copper oxide reacting with hydrochloric acid, barium carbonate reacting with sulfuric acid, hydrochloric acid reacting with calcium hydrogen carbonate, and calcium reacting with nitric acid. And the second question, you explain how you can prepare crystals of copper sulfate from 2 reagents of your salt. Whether you use an oxide and an acid, whether you use a hydroxide and an acid, it will depend on you, on your choice. And you give all the detailed steps we have to respect so as to get these crystals of copper sulfate. Thank you very much. See you next time.